Okay, let's take a look at this lab here. I don't feel like I did a good job explaining it, especially since I was looking at a previous older version than what you have. So please go ahead, and first step is this lab is going to be due on Friday morning, which is October the 3rd at 8 a.m. Put your name at the top. That is the due date. Now, what I do want to let you know is that if you have questions on Thursday when you come in, we can go over this lab then. And so a couple of things that you need to do is you needed to find the mass of that golf ball. If you didn't take the mass earlier this week on Tuesday, then you're more than welcome to go ahead and take the mass when you come to class on Thursday, not a problem. But you need that mass. Then, what I was looking at an older version, your version has two different distances, and that was a good question. Miss Munson, why is there two distances? On your version here, you are more than welcome to scratch that out because we are not going to take this lab at two different distances. Let me go ahead and please make sure you give me that distance in meters, right? That's what you use the string to find the location of the drop to the location of when that ball hit the ground. Turn the page. Go ahead and scratch this whole side out because we are not doing two different distances. Go ahead and give me that same distance that you have on page 1, add it over here on page 2, okay? Now that you have that over here, you already found the time for 10 different drops. You found it in seconds. Please don't forget your SI units. Then you're going to give me the average time in seconds. Now, in this box over here, I went over it, but kind of quickly in class. I don't feel like I did a good enough job, so that's the reason why I want to video this. What you are going to do is you're going to use your kinematic equations that we have already from Unit 2, and you're going to solve for the acceleration of your golf ball. So in this box right here, you are looking for A. Now, if I was you, I would probably come over here to the side and write in, remember the VI, the VF, the D, the T, and the A. Now, I'm telling you right here that the A is your unknown variable. T, do you have T? Yes, you do. T is located right here. So go ahead and get that T, plug it in. Do you have distance? Yes, you do. Remember, I asked you to write it from the first page right here and put it on the second page. So yes, you have distance. VF, you do not have the VF, but the VI. Because you are dropping this golf ball, that means that it's going to be in a free fall. Because it's in free fall, then your VI is 0, right? Go ahead and go through the kinematic flow chart and ask yourself those questions. Was D ever used, talked about, given, or looked for? Yes. Was T ever used, talked about, given, or looked for? Yes. And then go ahead and solve for A over here. Now, after you do that and show me your work, come to this spot over here and go ahead and scratch out distance 2. We shortcut this lab to only do one location, which was the 3rd floor on the LRC. Distance number 1, write that distance again. Give it to me again over here. Don't forget to always add your units. Then let's go ahead and for this box, I said it in class, but I think I kind of said it a little fast. You are going to solve for the mass. Okay, so let's do that. The mass of Earth equals A. Oh, you have A. You're going to utilize this A that you looked for. You're going to plug it in over here. Times R square divided by big G. Now, the R square and big G are going to be on page 3. Let me show you. Here they are over here. We've got this number right here, which is R, the radius of Earth, and big G is right here. That is your big G number. So those are the two numbers that you're going to need to solve for this second box over here. What are you looking for in this area or space is for the mass of Earth. And that's actually the title of this lab. That is your unknown variable, the mass of Earth. So you're going to go ahead and do that over here. Then we're going to turn it to page 3. On page 3, what you need is this box over here. Let's go ahead and scratch this out, and let's go ahead and scratch this out also. Let's focus on the third equation. The third equation, we have not done it in our notes yet, but we will look at this either Thursday or Friday of this week. It is the force equation. Force equals big G, oh, I have that number right here, multiplied by M1 times M2 divided by R squared. Do I have R squared? I do. It's this one right here, R squared. M1 is the mass of object 1, and for us, that's the mass of the ball. Okay? M2, you found that from page 2, the mass, M2, is the mass of Earth. So that number that you got on that other page, the mass of Earth, you're going to plug it here on page 1. With the scale, you found the mass of the ball. We can't put the Earth on a scale, so you had to do the math calculations to solve for that. Big G is that number. R squared, which is the radius of Earth over here, you're going to square it, and you're going to calculate in this box or this section right here, the force. The force has an SI unit in newtons, capital N for newtons. So force has an SI unit in newtons, and that's what you're calculating. I hope this helps with your lab a little bit more. I apologize for kind of going over it a little quickly. Hopefully this helps. If you have any questions regarding the lab, please email me so that way I can help you with that. If not, we can go over that in class on Thursday this week because it is due Friday morning at 8 a.m. The rest of this week we'll be going over notes, so please have your notes ready to go over later this week. Thank you for your help. Bye-bye.